Thank you. We worked on it for a long time, so.
I like it.
Check the clicker as well. It's at the back, the laptop. Okay.
So today, Hillary and I are going to talk about a big problem when it comes to companies, which is how can we allow for employees to access facilities in a secure and efficient way? So I'll give you an example. Last summer, when I was working at this fintech in Montreal, they took security very seriously. In fact, to access the databases, you had to secure yourself to a virtual private network, which encrypts all of your data transfers. So this is an example of where companies would need to be really secure. And another example would be like banking, right? The banks need to understand exactly who is entering the vault at what time, who they are, and basically authentication. Right? So the problem here is that we don't have a very secure way to authenticate people as of right now. We're still kind of in the ID land, Face ID land, ID card land. So what we're going to show today is how we can use facial recognition technology to fix this problem of old ID cards. So we talked about the problem a little bit. We talked about how, so we know that there's this problem with companies and how they need to secure their data. And we're going to present the solution of how we're going to use facial recognition technology to go about this. And the reason we're using facial recognition technology to secure company facility employee access is because it's kind of an emerging technology. And we're going to be one of the few companies that ends up capitalizing on this. Right, so what are some, let's kind of jump into the solution here. So what are some previous renditions of what we've seen before with facial recognition? We have, let's take the Apple iPhone. So Apple has Face ID. Face ID pretty much just takes this large angle, multiple photo spray of your face, and it converts it into, it basically allows you to authenticate into your phone just using your face, as we know. So Apple has a pretty good way of doing this, and so do airports, some airports around the world. In fact, some airports end up connecting to social media websites like Weibo and whatnot, and they can allow you to just enter the security checkpoint while only using your face. So the point is, there are some previous renditions that we're going to expand upon, and we're going to make much better here.
Right. So going back a little bit into the system overview of what we're trying to achieve, we're simply a contractor which is trying to implement a facial recognition technology service to a customer, like a company or someone who's trying to get this, maybe a bank who's trying to implement this system to secure one of their facilities. Mainly when you get at a door or at an access point, what you're trying to do is to authenticate yourself to be able to pass through. And this is the system that we're proposing, or the technology that we're proposing to do that. So what we have at the first stage is that you want to train a bunch of images in the same way that Apple Face ID, you take your photo, bunch of your photos of yourself rather, so that you can train it to authenticate you from time to time. But in this sense, we want to have images of the customer's employees or someone who works at that place. And what we do is we feed those images inside a machine learning model, which is probably on an offsite server, probably on AWS. We'll elaborate on what this means. And that machine learning model grabs a bunch of features that are characteristic or distinguished to a particular person. And we save those features inside a database. And what it means is that we have a 1:1 encoding of a certain characteristic of those features to a particular person. And on the second stage now is the authentication part. Is that when a person comes before a camera, the camera captures the image of the person, scans T, and then we send that image back to that same server. And that same server, the model on that server, has to reconstruct the same image or extract the same facial features out of that image, and then have a lookup in the database, whether to see those features are there. Because those features are kind of distinct to each and every person. And then once there's a lookup, you're able to send back that confirmation back that the person does have access to the company. So moving on, we want to see how ML models recognize faces, essentially. And we want to talk about convolutional neural networks, because this is a version of an ML model that can be able to extract features from an image and be able to have an encoding on it. So it's good at recognizing objects. And on the server, what we're doing is that we're running it on AWS, Amazon Web Services. So this is a cloud computing services. And we can be able to run what we call an EC2 instance, which is basically a supercomputer, which is being run on the cloud or in the internet. And you can configure how many processes you want and at what speed you want. And we have an algorithm, basically, which is what the ML machine learning model that we're going to use. And we're going to import it from Sky Biometrics API. And this is what we're going to use to simultaneously recognize the images, at the same time be able to detect whether a person you can recognize a person. But we're importing this model from another third party, which is called Sky Biometric Face Recognition and Detection. It's a new startup, it's credible, and we're using some of its resources. Because building our own model from the start, we can lose a little bit of credibility, but until then, we figure out how to build that model, we are importing one from another third-party source. So going back into how a model works, actually, how a convolutional model works, or what we're trying to grab, or the features that we're trying to extract out of a face. So suppose you have your own face. What we're trying to extract, for example, is having maybe one possibility of such an encoding is having a center of mass on your face, probably at the nose. And you can map other nodes, maybe your eyes, where your hair is, your beard, or your mouth. These are specifically other nodes on the face. And you have one central node on the nose. So maybe you're trying to get the distances of each and every one of those nodes from the nose. And then what it does is it takes that encoding of each distance probably and then put it in the database. So that's one way an ML model can learn your facial features. They're inexhaustible, but this is one way that is easy enough to understand and interpret. Going also how the convolutional neural network works or breaks down or finds these features is by basically shrinking down the image through a bunch of algorithm or functions, convolution, max pooling, and everything. But the idea is that you're shrinking down the image to the basic necessary characteristics that it has. So each image, to be able to distinguish it from one thing to another, there are some key samples that you can get or characteristics that you can get from the image that are smaller than actually the size of the whole image. So by doing that, you're just capitalizing on a few characteristics that differentiate images. So now let's go over to how the system can be broken down.
Yeah, so we can take a look at the system as a whole that we're proposing here. So we're going to start with the image of our person. So obviously the employee is going to walk into the bank and they're going to want to access the vault. What's going to happen is the camera is going to pick them up, and then the camera is going to send an API call to our server that we have on site that we're leasing out from Amazon Web Services. And this is going to be using the REST protocol. And so once the server ends up accepting this photo from the employee, what's going to happen is that it's going to send two different API calls. The first one is going to be to the Sky Biometrics convolutional neural network model that we discussed earlier, and this is going to auto-encode the face. So this is going to turn the face and the face mapping into 1001, which is going to show up on the database, which the server makes another call to, and it says, hey, did this 1001 encoding of the face, do we recognize it? Does this appear in the database? This is just like a hash map in Java or a dictionary in Python. We're going to say, does this key exist with a value? And so when it does, it's either going to authenticate and say yes or no. Now, let's take a look at some of the evaluations of our model, of the machine learning model specifically. So in terms of accuracy, we ended up researching the company that we're using right now, the Sky Biometry, and it turns out they have a 98% accuracy when it comes to their facial recognition technology, which is why we're using them. We think this is a good bet. And another thing is they provided an upper bound for how long the latency is going to last. So how long it takes for the machine learning model to kind of understand the face. And so that's about 3 seconds right there. And that's a upper bound for what it is. Do we have a question?
I was just going to ask, how, if it's not 100% accurate, why go for this method when you could just go for an ID card, which you know will always work?
That's a great question. There's a few things that we can do. So there's security and there's efficiency. So what we're hoping to do is that this will be cheaper and it'll be faster than the ID card method. Now, we'll get into a little bit later, but this is actually an opt-in system. So you don't actually, every employee doesn't actually have to opt into this system. So that's a great question though, and we'll circle back to that in the end. So in any case, we have this accuracy here, which is somewhat canonical for most machine learning algorithms. Machine learning algorithms typically, if they do better than, if they have a better accuracy rate than 95%, they're typically pretty good. And so this is what we're going to be using. And on that note, the more we implement this and the more customers that we implement this solution for, we're going to be hoping to train the model a lot better and get iterative performance. And so we want to be able to increase the accuracy and then decrease the latency, if that makes sense. So well, we can continue to evaluate here.
Yeah, so continue to evaluate it here. What we want to do is to be able to get a sense of how long the whole system takes from the right up to the time you get an image to the right up to the time you get it back or a confirmation back. So what we're going to do is just give a day-to-day interaction of our internet. And this is what we are using, our internet service, or what the company might use as their own internet service. But what we're trying to do is adopt this to give you an estimation of how long it takes. And here's how we're going to do it. So first, these are different internet companies that are on there, just a sample. But the idea that, or the two things that we're going to take away from this is the download speeds, or the bandwidth of the speeds that you can use to download and upload images, probably from 200 megabits per second to 940 megabits. That's how fast you can get, or the bandwidth that you're allowed to. And the latency, the time it takes for one bit to cross over to the other side, from one endpoint to another, between two links. And that's the same for these, that's the same idea for these two. And you can compare the price. This is per month, if you're, so that's how you can refer back to the cheapness of an internet system or things like that. But this is not ours. You can find it in a company or anywhere, but these are the top internet services in the country. How do we do so? So now, what you're trying to do is hook up a camera, a communication link between a camera and a server. And that communication link takes maybe from 100 megabits per second to 1,000 megabits per second. You get it from the internet company. And there's a latency of 50 milliseconds in between to get to the server, which we just saw that the internet service providers provided. So, and then from the server to the database, we estimate about 100 to 200 millisecond latency. Why? Because you're using the same service, AWS, so it's bound to be quicker than you would probably have if you're using an external database. So the idea to calculate this is, suppose that you have an image of about 1 megabyte to 100 megabytes. And you're trying to send that image to the server. So if that image is less than the bandwidth or the upload or download times, it means that you can be able to send it within the latency time that is given. So an image, basically what we're trying to give it is the upper bounds. 1 megabyte be the smallest, 100 megabytes be the maximum. You can increase it. And then we ship that image in under 50 milliseconds to the server. And then when the server takes 3 seconds, to process the image, it sends that encoding back to the database or confirmation to the database. That takes around 200 milliseconds. So in total, the time that we have is probably around 3.5 seconds. The reason why is because it takes 50 milliseconds to go to the server. It also takes another 50 milliseconds to come from the server. So that's 100 milliseconds. It takes 200 milliseconds to get to the database, another 200 milliseconds to pass from the database to the server again. So that's 400 milliseconds. So you have 500 milliseconds, which is half a second, plus 3 seconds that's in between to process the image. So in total, your round trip time coming back and forth is about 3.5 milliseconds. So going forward, that's how you evaluate a system in terms of this system, in terms of how long it takes, right from the time you get an image to the time you get the confirmation. And now we want to go into how long it takes for us to implement this system if someone comes back and says, hey, we want to adopt this system in our facility. Well, basically to get the data, it just takes us about a day to collect. We work with the sample size first. So collecting data from people in case available, maybe about a day to 2-3 days, depending on the availability of people, just to get pictures and be able to assemble the data. To work with Sky Biometrics and import the algorithm locally, like on a local computer, to test the algorithm, that takes us about a week or so. And then we take another week also to debug. So in this entire process that we have in a month, we have set up this, gotten the data, set up the server locally, and also we've debugged kind of like any loopholes between setting it up. And now we want to set up a server online as well. So we go into the next step, which is to set up a AWS server or EC2 instance. This takes out usually a period of about 3 days to 1 week, depending on how things are working. But it's not much of a big deal to set up a server. And then we're now going to phase 2.
Right, and phase 2 is going to be the beta testing. So at first what we're going to do is we're going to upload our training data so we can train the machine learning model to S3, which is a cloud service that you can just hold a bunch of images and whatever you want. And then and this is going to take a little bit. It's going to take maybe a few weeks here and into the next month of July. And then what we're going to do then is configure the ML model. So we talked about how we're going to do the sky biometry algorithm, and we're going to use that. And so we're going to make sure that we can have that ready to go here. So once we do that, what we're going to do is we're going to set up the database. So we mentioned that this is important for the authentication. So basically what we're doing here is we're continuing to set up and kind of putting all the pipelines together. As we can see here, the authentication pipeline is going to come after the database, right? So we're hitting the technical points here. And finally, just to make sure everything is correct, we're going to make sure to spend some time debugging here, which we have near October. Now, that brings us to phase 3, which is optimizing, right? So after we put everything together in phase 2, how can we make everything run efficiently and smoothly, right? So here we're going to research the data transfer. So we were talking about the 3-second latency. We were talking about the accuracy. So we're thinking about how we can decrease the latency when it comes to these sorts of things. And another thing we want to do is set up the high-tech cameras, because in the beta testing and the setup testing, we were simply running the algorithm to test it out on our own local machine. So now what we're doing is we've proven that it worked with the local machine, and now what we're going to do is actually set up the pipeline using the cameras and the servers, if that makes sense. So basically, instead of running the algorithm on our machine, we're going to be running it on the server. And then we're going to spend some time debugging, and finally we're going to deploy the system. This takes us through end of December 2022. Yeah, so this is our time plan, and we just want to hit a few more points and then wrap this up here. So the idea is, what happens, we were talking about false positives and false negatives. What happens when this happens, right? Well, at first, we know that in machine learning, this is to be expected, and especially with an emerging technology like this. But we need to make the leap to this facial recognition technology in order to continue to improve here. So it's kind of like an analogy could be the horse carriage jumping to the car. Maybe the car will actually break down.
Try and wrap up in a minute.
In a minute? Okay, sounds good. Another thing we were going to talk about is privacy and ethics. So we were talking about the opt-in system earlier. So employees can opt in or opt out based on whether or not the CEOs purchased this for their company. So we just wanted to hit that. So in summary, what we want to talk about is this.
So what we're trying to do here is just to secure facility access using facial recognition technology. And the idea is to use machine learning models to be able to extract certain features from an image which are characteristic and distinguished to a certain person. And in doing that, these ML models help us to extract particularly the convolutional neural networks. And in all that, we're able to provide a service that is essential for authenticating facility access. Thank you.
Thank you. Very nice. Again, both of you guys are presenting very, very well. And I like the fact that you're trading off. I got tired of some of the other things where somebody got up and spoke for 10 minutes and the other person was standing there like a statue and they traded off. But you guys do really well trading off. I guess one of the issues is, Face ID. There's been a lot of experience with Face ID. And some of it's good in that you've identified a company that has an algorithm. It wasn't clear to me whether you said you're using their algorithm or whether you're using their model. I wasn't clear which one you were doing.
So we are using their algorithm via an API call, and we're going to be using it on our own machine that we're leasing from the cloud service.
Yeah, that's fine, but the question, are you really using their model and their identification? Do they have have they done any data that's part of the thing, or is it simply their algorithm?
Oh,
Just
yeah.
be clear, just be clear of that.
Oh, I see.
Right, I mean, normally you would say we're using their model, if
Yeah,
right, if it's true.
right.
Right.
Yeah.
Right. At one point, you talked about what you're doing as a company. Is that what you mean?
Yes. So in general, this is a system that would implement.
Right, so one of the things you're gonna need to do, it's nice that you presented a plan and a Gantt chart, but what you didn't say is who's working on this? Is it
Okay.
just the two of you?
Yeah, in fact, I think we have a spot here assigned to, and so we didn't really hit it while we were speaking.
Is this a 10-person startup? Is this the two of you? You need to say what's going on.
Right.
Okay? The other thing that you got to a little bit at the end is risks. I think you blew off the security ethics thing, because you know that's a big deal. If you look at what the TSA is doing, they said they're announcing this. They got major objections, both about ethics and security. And you guys said, well, we'll worry about ethics because the CEO purchased it or something.
Right, but it's a private deal, whereas in the TSA, it's public, it's for millions of people accessing the
I
airport.
understand, right? Nonetheless, suppose what choice did the company employees have? If it's really a private deal, what are the security issues around it? You didn't say anything about the security of the database and the security of the server. I mean, that's a big deal. Do you think that a company, can you imagine MIT listing this without doing amazing evaluation of the security of the database with pictures of everybody at MIT on it? That's a big deal, so you need to think about that. You don't have to solve it now, but in general, when you're presenting a timeline like this, you're going to need to talk about the risks.
That's right. Isn't AWS already, doesn't its security speak for itself? That's why MIT is already using AWS for their COVID pass systems and everything.
Yeah. There's a lot of security other than saying, oh, we're using AWS.
Yeah.
There's the servers, there's who has access to the thing, there's the rogue IT person in your organization who's deciding to sell everybody's identity for things. Security is not an easy thing, and I don't expect you to solve it and stop.
Yeah.
But you really need to respect that there are issues there.
Yeah.
Yeah, I think on that point, like even if, say, AWS's security act speaks for itself, I think also think about who you're presenting this to. So you might be given this idea, you might be presenting it to someone who's maybe not had that much experience with working with different storage systems, and they just don't know. And so you can say, on that topic, right, if it's going to be AWS or whatever it is, you reassuring that that's taken care of instead of assuming that they get it.
That's like saying, look at all the break-ins that you found over the last year. Oh, guess what? None of them happened in AWS, right?
Yeah.
That's kind of what you're saying. You want to say a little bit about accuracy, because that little thing that says we have 1 day to get the pictures. How large an organization are you talking about?
Oh, in this initial setup, it's just a sample size that we're grabbing.
Okay, but when you really want to deploy this, it's a big deal,
Oh, yeah.
right? There's also issues in Face ID like lighting and stuff. There's lighting both when you're taking the picture and when you're trying to identify somebody. Suppose.
Racial bias as well.
Yeah, there's bias in all this stuff, but there's stuff, suppose I'm going to walk through the thing, but I've turned my head.
Yeah.
Is the system going to work?
It is going to work. I looked it up and I read it in their website that I showed. From multiple angles, it says, just on the bio.
Oh, okay, so then you want to think about it. So you want to think about that. I thought you did a little bit too much, I don't know, I don't care so much about CNNs, right? Right, everybody knows, hey, you do various kinds of identification with CNNs.
Yeah.
Well, CNNs will be obsolete in 3 years because everybody's going to transformers. But
Yeah, we wanted to be more technical. That's why we put a lot of emphasis on that in this presentation.
yeah, I was just sort of seeing CNNs is fine. I'm not exactly sure why you mentioned Relo. That's like a detail in how you do it and stuff.
Yeah.
And then the other thing that was a little bit confusing, you meant to say this is binary encoded, and instead you say it changes it into 1001. So I understood what you're doing, but I didn't know when you first said it, what you really meant.
Wait, but what's the difference between those two?
You say it's binary encoded.
Technical, more technical aspect of.
Okay, so I could, it's not a technical term.
Well, I mean, when you said 1001, I didn't know what you actually meant. Did you mean literally
Oh.
that you had a code?
Oh, I understand, I see.
Okay, it's good that you researched the company. The question about the ID card was good. It showed that as much as you started this, you didn't really do enough motivation for why the system's better. You came back and when you answered his question, you said more. But start up with a little bit more about, what do people normally say? You lose the ID card, and it's stolen.
Exactly.
And it's basically, what are people talking about? Two and three factor authentication, rather than just one factor. It's
Yeah.
a standard argument for that. So those are mostly minor comments.
Oh, okay.
I think that's fine. Say a little, but I got a little confused in that about the size. When I think about this stuff, I think a lot about the size of the organization in which you're deploying it.
Right.
So I got confused there. Were you talking about just your little experimental system, or you need it for, how are you going to test for a small organization? How are you going to test whether it works or not? Because I assume you can always recognize 10 employees pretty competently.
Right.
Right, but when you have
Simple size.
500 of them, then there's an issue. So you need to think about that as one of the risks in your deployment.
Okay.
Right, it's easy to make a small experimental system, but you're talking about really deploying something, and there's a whole other set of risks, including what you guys said, that the guys running the company are saying, oh God, this computer stuff doesn't work, I know there's security, I don't care about it, I just know it's not gonna work, I'm not gonna bet my company on this. Right, so you gotta really be clear about who this is for and who you need to explain it to.
I think there's just also one thing I wish you kind of touched on. So you talked about the actual server and everything like that, and that was a good explanation, I believe. I kind of wish y'all talked about what the person's actually looking at. You said just a camera, but is this a camera? What type of camera is it?
Yeah.
Are they just is it gonna be on a door? You didn't talk about the local system that's gonna
Right.
be taking the pictures and actually sending it. So I wish y'all kind of touched on that, and maybe if price and things like that, the type of resources that you're going to need in order to install that on every door, or if it's just going to be on entry or something.
Right, yeah, we wanted to steer away from price. We didn't want to be hit with the comment about,
Yeah,
oh, this isn't
don't
a startup
mention it.
pitch.
Yeah, this isn't about price and stuff, this
So,
is really
yeah,
much more about technical feasibility.
yeah, I guess maybe we could have discussed more on maybe the camera types that we are using, the resolution, because there's some cameras that are pretty good at something.
Okay. So, some small comments, but really nice.
Awesome.
Okay.
Thank you so much.
You're not
no,
gonna
this
fight
is-
it.
Should we be taking notes, Hal?
It's
Or-
also stand on.
Yeah.
Hal? Should we be taking notes or something?
Doesn't matter. We're all sort of crawling to the end of the semester.
Oh, man.
I mean, if you want to write down notes, do it.
No, I am good. Thanks so much, Hal.
Is the video starting?
I don't think we stopped the video.
Just keep going. On, let me check.
I think I just got it going.
Okay, all right.
Alright. Go, you, start.
Whenever you're ready.
Hi, my name is DeWitt,
I'm Julian.
and we're going to be talking about a proposal for a Fermi estimation model. So what are we actually going to be proposing? We want to write a program that can take a vague